Alright, in this technique, factorization doesn't work. We see fractions within fractions. So we need some sort of new idea. Whenever we see fractions within fractions, then the good technique is just combine them. Try to clean things up and make it one big fraction. Now, let's try to rewrite this by combining the fractions at first. But first, let's make sure that it is 0 over 0 condition. So when you insert 0 for x, 1 over 4 minus 1 over 4 is 0, 0 at the top, 0 at the bottom, yes, 0 over 0 condition. So as in the first technique, we will rewrite in an equivalent form of the limit. So limit as x approaches to 0 of, so what I see here are two different fractions. How do I combine them and make one big fraction? It's a simplification technique. We will just get a common denominator, as you can see. So how do you get the common denominator? One of the denominators is x plus 4, the other one is 4. There are two different denominators, so make them same by multiplying them by each other. So multiply this first one by 4, second one by x plus 4. So in this case, we will have, let me clear here a bit. So in this case, we will multiply the first part by 4, top and bottom by 4, second part by x plus 4. Top and bottom will be multiplied by x plus 4. So what will we have here? So 4 at the top minus x plus 4. So there is a common mistake here using minus for x only. It is not just for x. This minus belongs to the whole numerator. So distribute this minus. Minus x minus plus minus 4. Alright? Divided by the common denominator. What is the common denominator now? The common denominator becomes 4 multiplied by x plus 4. Okay, all over x. Let's simplify the top. I can see 4 minus 4 here, so it will give me limit as x approaches to 0 of negative x divided by 4 multiplied by x plus 4 all over x. Now I wrote the top as one big fraction. Now I'm gonna write all as a huge fraction. Okay, I see still fraction within fraction. So remember, when you have something like a over b all over c over d, how do you solve these kind of questions? How do you simplify it? You keep the top, a over b, and multiply it by reciprocal of the bottom. So instead of c over d, write d over c and multiply. We will use the same idea here. So we will write this as limit as x approaches to 0 of, the top fraction is negative x, 4 times x plus 4, and the bottom fraction is x over 1. So flip the bottom fraction, x over 1 becomes 1 over x. Now there is cancellation. X's will cancel each other. I'll have 1 over 4 times x plus 4. Now direct substitution. Let's plug in 0. So it's going to be limit as x approaches to 0 of negative 1 divided by 4 multiplied by 0 plus 4, which will give me negative 1 divided by 4 times 4, 16. So answer of this question is negative 1 over 16. Alright. So let's solve one more question, one more similar question, a ministry question. So again, we have fraction within fraction. So we will use the same technique. We will combine the fractions at the top first. Let's combine the fractions at top by multiplying the denominators by each other, right? So you will multiply left side by x plus 1. Top and bottom will be multiplied by x plus 1. The right part, top and bottom will be multiplied by the other one, the denominator of the other fraction, x minus 1. So how do I rewrite this? Limit as x approaches to 0 of the top becomes x plus 1 plus x minus 1 divided by the common denominator, x plus 1 times x minus 1. What is x plus 1 times x minus 1? I can see difference of two perfect squares, x squared minus y squared, right? So I can factor this out as x squared minus 1 all over 2x. Now I can see cancellation. Ones will cancel each other. I will be left with limit as x approaches to 0 of x plus x2x divided by x squared minus 1 all over 2x. Now I got a big fraction at the top. I'm gonna have a huge fraction now. By keeping the top fraction and multiplying it by the reciprocal of the bottom fraction. So write this as limit as x approaches to 0 of top fraction, which is 2x over x squared minus 1, multiplied by reciprocal of bottom fraction, 1 over 2x. Now, two x's will cancel out each other. I will left with limit as x approaches to 0 of 1 divided by x squared minus 1. I am done with simplifying. This complicated fraction becomes this simple fraction, 1 over x squared minus 1. I just have a huge fraction here at the end. This is an equivalent form of the first complicated given limit. So all I have to do is now substitute substitute 0 for x. So limit as x approaches to 0 of 1 divided by x becomes 0. 0 squared minus 1. So 1 over minus 1 minus 1, which gives me option A. Alright, I think you got the idea. Two questions are enough to get the idea of this technique. Okay, let's move on with the other technique, the last technique, rationalizing technique. So this technique involves radical. So what is the way of rewriting the radicals? Do you remember the way of rewriting the radicals? Let me remind you something. Let's suppose you solved a question, a big question, and at the end you get 1 over square root of 3. It's a multiple choice question and you don't see 1 over square root 3 in the options. What would you do? You would rationalize it, right? You multiply top and bottom by the conjugate of the bottom. So you get square root 3 over 3. That would be the simplest form after rationalizing. So we will use the same technique here. We will rationalize it by multiplying top and bottom by the conjugate of the radical part. Sometimes in some questions the radical part is at the bottom. For some questions it's at the top. It doesn't matter where it is. We just have to multiply top and bottom by conjugate of the radical part. Alright, so let's make sure whether we have 0 over 0 case first by inserting 0 for x, 0 at the top, square root 4 is 2, 2 minus 2, 0, 0 at the bottom. So we see 0 over 0 case, so we're good to go. We will apply the rule. Rationalizing. Let's do this. First, write this as limit as x approaches to 0 of x divided by square root x plus 4 minus 2. So what's the conjugate of square root x plus 4 minus 2? It is, we studied conjugates in grade 11 and grade 10 too. Some of you will remember. So the conjugate is, you keep the radical part, square root x plus 4. You also keep the other number. You just change the sign in between. In between I have negative, so make it positive. That's its conjugate. Okay, so multiply this by top and bottom. Now do not touch this part. I will need it to simplify it. You just factor out the um, expand the bottom part here. Keep this factored out, just expand the bottom. How do you expand it? There's something minus something times something plus some other thing. It's like a minus b times a plus b. How do you factorize this condition? How do you factor these kind of uh, products? A minus b times a plus b. This a squared minus b squared, right? So I can use the same here. Instead of distributing one by one, taking my time, I can just apply this. I write this as first one squared minus second one squared. So limit as x approaches to 0 of keep the top. I will need it in factored form, divided by the bottom will be square of the first one. It's gonna be x plus 4. The radical will lift off, minus square of the second one, 2 squared 4. So 4's will cancel each other, so I will have x at the top and x at the bottom. So limits as x approaches to 0 of x multiplied by square root x plus 4 plus 2 in numerator, and denominator I am left with x. And as you can see, there are x's at the top and bottom. They will cancel out each other. So I am left with this. This is the last form. This is the simplest form. I can't simplify it anymore. I am done simplifying. So this complicated fraction becomes this simple function, right? So as in the previous questions, what we need to do is always plug in. So we substitute the number that x is approaching for x. Limit as x approaches to 0 of square root of 0 plus 4 plus 2. Square root of 4 is 2. 2 plus 2 makes 4. Alright? So the answer is 4. Okay, one last question and I will finish the lesson. So this one. In this question, the radical part was at the bottom. In this question, the radical part is at the top. I chose these two different questions to show you there is no difference actually. We use the same way. So direct substitution to see if we have 0 over 0 case. Square root 5 minus square root 5 is 0. 0 at the top, 0 at the bottom. So yes, I have 0 over 0 case. Now rewrite the function by using conjugate rationalizing. This time our radical part is at the top, so we will rationalize it. We will multiply top and bottom by conjugate of the top. So limit as x approaches to 0 of square root x plus 5 minus square root 5 divided by x. So what is the conjugate of square root x plus 5 minus square root 5? It is, you keep the first term, square root x plus 5, keep the second term, square root 5, and just change the sign in between. Negative becomes positive. And you don't just multiply this by the top, you also multiply it by the bottom to keep the balance. So do not touch the bottom. It's already factored out. So just factorize the top here. Expand the top. It is as in the previous question. A minus b times a plus b form. So it's difference of two perfect squares. Without distributing one by one, you apply difference of two perfect squares. A minus b times a plus b is a squared minus b squared, right? So first one squared, square root x plus 5 squared is just x plus 5, square root will lift off, minus square root 5 squared is just 5, square root will lift off, all over x divided by this. Okay, so 5's will cancel each other. I will left with x at the top and x by this factor remains. So I can simplify x's and I will I will be left with limit as x approach to 0 of only 1 at the top, at the bottom, this radical part. Now I am done simplifying. Actually, it doesn't look simpler than this, but it's not always about simplifying. It's about rewriting. Even though this doesn't look simpler than the given question, this is how we can rewrite this, and it will help us to solve the question, whether it's simple or not. So now, substitute the x value for x in the function. Limit as x approaches to 0 of 1 divided by square root of 0 plus 5 plus square root of 5. So it's gonna be 1 over square root 5 plus square root 5 to square root of 5. If you see this in options, this is your answer. If you don't see this one in options, you will rationalize the number. All right. So we are done with three techniques all. We covered all of the techniques, and those are the similar questions for each technique.